Hello again. So my name is George Green, and at this point, I would like to offer a typical contour test, which is made up by three problems for your consideration. This contour test is related to statistical mechanics for chemists, okay? And it has been taken from from a textbook which was published for chemistry department for the chemistry department of the Moscow State University. But this is the lowest difficulty level problem set. For that reason, I just want you to understand that you are expected to be able to deal with these problems effectively, making no mistakes. But we can't just pass by these problems saying, oh, they are easy to deal with. Actually, they are not that easy to deal with. And maybe a bit later, I will offer a higher level contour test related to the statistics for chemists. Okay. Now let's start from the lowest level of difficulty. So the first problem is going to appear on the screen of your computers right now. Hold on a second, please. Here it is. Yeah. So I will try to explain the solution to this problem in two languages, in Russian first, and then in English first, and then in Russian. So the first problem is the following. So the most probable velocity of the molecules of some gas is 4 times as much as the velocity of sound in the air at 149 degrees Celsius. Determine the gas. Okay, so let's start from the beginning. And what we should start from is to put down the data correctly. So we've got the velocity, most probable velocity, which is 4 times as much as the velocity of the sound, right? Okay. Also, we've got the temperature, but we should convert Celsius into Kelvin by adding to 173. And if we do this, we will get the temperature is 422 Kelvin, right? And we should remember, if you don't remember, it's not a big problem. You can get it from any reference book that the speed of sound in the air is roughly 331 meters per second. Okay. So this is what we got under the conditions of this problem. Okay. And they want us to determine the gas. How can we do that? So the first thing which comes to my mind is that if we determine a smaller mass, so we are able to say which gas it is. Now, let's remember the course of standard physics, and it taught us that the most probable velocity of molecules is equal to square root out of double gas constant R times temperature T divided by the molar mass of the gas. Okay, we've got everything, but we remember that this term is equal 4 times the velocity of speed. For that reason, instead of this term, we can write 4 times V sub S. S stands for sound, is equal to the square root of double RT over mu. You should remember that in physics and in physical chemistry, mu often denotes the molar mass of substance. Okay, but the problem is that mu is under the square root. For that reason, in order to say goodbye to the radical, we should raise the left and the right parts of this equation to the second degree. Okay, in this case, we will get the following: 16 V sub S squared is equal to double RT over mu, right? In this case, mu is equal to RT divided by 8 V sub S squared, right? Okay, so our next step is to plug in the values, numerical values of these terms into this formula. So not V, but mu is equal to, so the gas constant value is 8.314 joules per mole per Kelvin. Okay, the temperature is equal to 422 kelvins, right? And we divided it by 331 squared meter per second squared. Okay, and we've got a calculator, so we will get 4.00 times 10 raised to the minus third kilogram per mole. So, and we look at the periodical table, we will see that it is the molar mass of helium. So we've just identified the type of the molecules of the gas. It's helium. However, this is not the end of the solution. What we need to do to make sure that we stand a chance to get a high score for our solution is to see to the measurement units. Okay, so we've got this formula, right? So joules per mole per Kelvin, this is for R, Kelvin for temperature. Okay, and we divide by meter squared second squared, right? Okay, kelvins get cancelled. Okay, joules, joule is the measurement unit of work, and work, if you remember that work its formula is force times distance, right? So the unit measurement unit of force is Newton, and that for distance is meter, of course, right? And this is what we have written instead of joules, right? Moles, meter squared and second squared. Okay. No, we divide. For that reason, we should put this fraction upward. Second squared, meter squared, right? And now instead of division, we write multiplication symbol. So in this case, m get cancelled partially. Okay, and now we got Newton, but we remember that Newton is the measurement unit of force, and force, according to the second law of Newton, force is the product of the mass of an object and its acceleration a. The measurement unit of mass is kilogram, and that for acceleration is meter per second squared. So now let us write it instead of n, it's kilogram times meter over square seconds, right? It's this term divided by mole. Meter cancelled, and we finally got, sorry, we finally got 1 kilogram per mole. And this is a typical measurement unit of moles, I'm sorry, of molar mass, which means that we are on the right track. Okay, this is the end of the solution. In the answer, we can write helium. That's it. Okay, now I will repeat. I will go over the solution to this problem in Russian briefly. Итак, у нас есть с вами формула для скорости, наиболее вероятной скорости. Это корень квадратный из 2rt на μ. Мы также знаем, что по условию задачи эта скорость в 4 раза выше скорости звука, поэтому вместо вот этого мы поставляем вот 4v, можно писать zv, звука. Возводим в квадрат обе части, делаем простейшее преобразование, выражаем из этого уравнение μ. Вот оно, это выражение, подставляем часовые значения и получаем вот это вот часовое значение. Но нужно помнить, что мы должны показать экзаменатору, преподавателю, что мы знаем, что такое у нас единицы измерения, что они должны соответствовать той формуле, которую мы получили. Поэтому вместо, мы пишем джоуль на моль Кельвин, это для R, для газовой постоянной температура Кельвин. Здесь у нас что? Квадрат скорости, поэтому метр квадрат на секунду квадрат мы делим, поэтому мы потом переворачиваем, вот идет вот так вот. Метр частично сокращается. Ньютон – это единица измерения, вернее, джоуль – это единица измерения работы. Работа у нас измеряется по формуле сила, умноженная на расстояние, то есть это ньютон на метр. Это мы пишем вместо джоуль. Поэтому вот эти метры частично сокращаются. Ньютон, в свою очередь, это единица измерения силы, а сила по второму закону Ньютона – это ма. М – это килограммы, а – это ускорение метра секунды в квадрате. Подставляем вместо Ньютона килограмм на метр секунды в квадрате. Это все прекрасно сокращается, остается килограмм на моль. А килограмм на моль – это единица измерения малярной массы. So let's proceed to the second problem. Here it is. So, using the equipartition theorem, estimate the molar heat capacity of carbon monoxide at room temperature or indoor temperature. Okay, let's start from the very beginning. And our first step is to understand where we can get the molar heat capacity from. Well, it's the Mayer equation. Mayer equation is C sub P is equal to C sub V plus the gas constant R, where C sub P denotes heat capacity at constant pressure, while C sub V denotes the same but at constant volume. Okay, and in order to estimate C sub P, yeah, we are expected to calculate C sub P. We should first of all calculate C sub V. And in order to do that, we should understand that there are a few inputs into the numerical value of the heat capacity. The first input is so-called translation movement, translation movement input. Okay, we can write that C sub V of the translation movement is equal to I sub TR, which stands for translation movement, times gas constant R divided by 2. And we remember that for molecules of any type, I is the degree of freedom of translation movement, right? And it's equal to 3. 3 times R over 2. And now instead of R, we plug in its value, 8.314 over 2. And it is equal to 12.471 joules per mole per Kelvin. Okay, this is the first input of the translation movement of the molecules of this gas. The second input is rotatory movement input, right? C of V. Rot means stands for rotatory. Rotation is equal to I. We index ROT times R over 2. Okay. And for this molecule, for the CO molecule, it's linear molecule which consists of 2 atoms. I rotatory is equal to 2. And finally, we've got that this value is equal to 8.314 joules per mole per Kelvin. Okay. And there is another one. It's C sub V sub oscillation. Yes. But the fact is that under the terms of this problem, the conditions of this problem, the temperature is indoor temperature. For that reason, at indoor temperatures, oscillations of atoms which make up a molecule are frozen. For that reason, it's equal to 0. Because the indoor temperature, because of the indoor temperature. In other words, we can write that C sub V is equal to C sub V sub translation plus C sub V sub rotatory, and we'll plug in their values, okay, plus 8.314, and we've got 20.785 joules per mole Kelvin, right? Okay. And now using the Mayer equation, we can compute the value of C sub P. C sub P is equal to 20 sub 785 plus 8.314, and it's equal to 29.099 joules per mole per Kelvin. And this is the value which is very close to the one which you can find in any reference book for this substance. That's it. Now a couple of words in Russian. Итак, у нас с вами есть, значит, с чего начинаем? С того, что, чтобы найти CP, мы должны использовать уравнение Майера. Оно известно. Понятно, что чтобы найти CP, нужно найти CV. А CV складывается из 3 компонентов. Это CV поступательного движения, вот оно, его формула, CV из вращательного движения и CV из колебательного движения. Но сразу скажу, что при комнатных температурах колебательное движение замороженным считается, поэтому этот вклад равен нулю. Значит, И это степень свободы, да, значит, поступательное движение, она для всех частиц равна 3. Подставляем, получаем вот это значение. Для вращательного движения у нас степень свободы для этой молекулы двухатомной линейной равна 2, поэтому двойки сокращаются, получается 8,314. Складываем и получаем CV, то есть значит, теплоемкость при постоянном объеме вот такое. Она над при постоянном давлении. То есть добавляем еще 8,314, это вот это газопостояние, получаем это значение. Вот и все. Спасибо. Okay, I hope that you're ready to get down to the third problem. Well, before we set to solve this problem, I want to say that you ought to remember all the formulas we have previously used in order to do the calculations, okay? And this is not an exception to this train. So the problem is going to appear on the screen of the computers in no time. So here it is. Calculate the translation input into the entropy of chlorine at 27 degrees Celsius and 0.95 atmospheres. Okay. So first of all, let's write down what we've got. We've got chlorine, and that means that we know its molecular weight, right, or molar weight. It's roughly 71 times 10 raised to minus third kilograms per mole. Okay. Also, we've got temperature, and we convert Celsius degrees into kelvins by adding 273, and finally we got 300 kelvins. Okay. and we've got pressure 0.95 atmospheres, and we convert it into pascals by multiplying this value by 800 and 1,825 pascals. Okay, so that's what we've got, and they want us to calculate the translation input into the entropy of the molecules of chlorine. Okay, I would say that this is the easiest assignment to do, because in order to get the right answer, all we need to do is to recollect the formula, which we have used previously numerous times. Here it is. TR stands for translation movement, okay, and is equal to R times 3/2 times natural logarithm of the molar mass of this gas plus 5/2 times natural logarithm of the temperature minus natural logarithm of the pressure. But remember that the measurement units of the pressure should be converted into pascals, not any other, plus 20.75. This formula have been derived previously, and it shouldn't bring about great problems, because we used it before many times, as I said above. And now all we need to do is just to put the numerical values of all the terms. This is the value of the gas constant, okay, 3/2 times the logarithm 71 times 10 raised to the minus third plus 5/2 logarithm. And the temperature is, I'm sorry, it's not 5 but 300 Kelvin, so minus logarithm of this 95 times this, because this is the number of pascals in 1 atmosphere, this one. Okay, and plus 20.75. And if you've got a calculator and do the calculation, so the final answer should be 162.68 joules per mole Kelvin. This is the answer. That's it. Now a few words in Russian. Итак, я считаю, что эта задача одна из самых простых. Единственное, что вы должны помнить, это вот эту формулу. Мы ее раньше выводили, и она раньше использовалась неоднократно, поэтому с этим проблем у вас быть не должно. Написали ее, вспомнили и подставляем значение. Помним, что температура из Цельсия в Кельвин. Малярная масса всегда не грамм на моль, а килограмм на моль. То есть мы работаем в системе Си. Паскали, вернее, значит, эти pressure, давление у нас не в паскале. Вернее, извините, не в атмосферах, а именно только в паскале. Поэтому мы переводим паскали, умножаем на 101/125. Столько паскалей в одной атмосфере. И плюс 20,75. И при помощи калькулятора получается это значение. Вот и все.